Aluminium oxide is a chemical compound of aluminium and oxygen with the chemical formula Al2O3. It is the most commonly occurring of several aluminium oxides, and specifically identified as aluminium oxide. It is commonly called alumina, and may also be called aloxide, aloxite, or alundum depending on particular forms or applications. It commonly occurs in its crystalline polymorphic phase I plus or minus Al2O3, in which it comprises the mineral corundum, varieties of which form the precious gems ruby and sapphire. Al2O3 is significant in its use to produce aluminium metal, as an abrasive owing to its hardness, and as a refractory material owing to its high melting point. Natural occurrence: corundum is the most common naturally occurring crystalline form of aluminium oxide. Rubies and sapphires are gem-quality forms of corundum, which owe their characteristic colors to trace impurities. Rubies are given their characteristic deep red color and their laser qualities by traces of chromium. Sapphires come in different colors given by various other impurities, such as iron and titanium. Properties: Al2O3 is an electrical insulator but has a relatively high thermal conductivity for a ceramic material. Aluminium oxide is insoluble in water. In its most commonly occurring crystalline form, called corundum or I plus or minus aluminium oxide, its hardness makes it suitable for use as an abrasive and as a component in cutting tools. Aluminium oxide is responsible for the resistance of metallic aluminium to weathering. Metallic aluminium is very reactive with atmospheric oxygen, and a thin passivation layer of aluminium oxide forms on any exposed aluminium surface. This layer protects the metal from further oxidation. The thickness and properties of this oxide layer can be enhanced using a process called anodizing. A number of alloys, such as aluminium bronzes, exploit this property by including a proportion of aluminium in the alloy to enhance corrosion resistance. The aluminium oxide generated by anodizing is typically amorphous, but discharge-assisted oxidation processes such as plasma or electrolytic oxidation result in a significant proportion of crystalline aluminium oxide in the coating, enhancing its hardness. Aluminium oxide was taken off the United States Environmental Protection Agency's chemicals lists in 1988. Aluminium oxide is on EPA's Toxics Release Inventory list if it is a fibrous form. Amphoteric nature: aluminium oxide is an amphoteric substance, meaning it can react with both acids and bases, such as hydrofluoric acid and sodium hydroxide, acting as an acid with a base and a base with an acid, neutralizing the other and producing a salt. Al2O3 plus 6HF at 2 Alf3 plus 3 hours duo, Al2O3 plus 6 NaO plus 3 hours duo A2 Nal3 Al, OH, 6, structure. The most common form of crystalline aluminium oxide is known as corundum, which is the thermodynamically stable form. The oxygen ions nearly form a hexagonal close-packed structure with aluminium ions filling 2/3 of the octahedral interstices. Each Al3+ center is octahedral. In terms of its crystallography, corundum adopts a trigonal Bravais lattice with a space group of R3C. The primitive cell contains 2 formula units of aluminium oxide. Aluminium oxide also exists in other phases, including the cubic I cubed and I phases, the monoclinic I phase, the hexagonal I phase, the orthorhombic I phase and the I phase that can be tetragonal or orthorhombic. Each has a unique crystal structure and properties. Cubic I cubed Al2O3 has important technical applications. The so-called I-squared Al2O3 proved to be NaAl 11017. Molten aluminium oxide near the melting temperature is roughly 2/3 tetrahedral, as 1/3 5-coordinated, very little octahedral allo is present. Around 80% of the oxygen atoms are shared among 3 or more allo polyhedra, and the majority of interpolyhedral connections are corner sharing, with the remaining 10–20% being edge sharing. The breakdown of octahedra upon melting is accompanied by a relatively large volume increase. The density of the liquid close to its melting point is 2.93 grams per centimeter 3. Production: aluminium hydroxide minerals are the main component of bauxite, the principal ore of aluminium. A mixture of the minerals comprise bauxite ore, including gibbsite 3, boehmite, and diaspore, along with impurities of iron oxides and hydroxides, quartz and clay minerals. Bauxites are found in laterites. Bauxite is purified by the Bayer process, AlO, OH, plus H2O plus NaOH Al, OH, 4, Al, OH, 3 plus NaOH Al, OH, 4, except for CO2, the other components of bauxite do not dissolve in base. Upon filtering the basic mixture, Fe2O3 is removed. When the Bayer liquor is cooled, Al, OH, 3 precipitates, leaving the silicates in solution. Na-Al, OH, 4 and NaO plus Al, OH, 3, the solid Al, OH, 3 gibbsite is then calcined to give aluminium oxide, 2 a Euro Al, OH, 3 Al2O3 plus 3 a Euro H2O. The product aluminium oxide tends to be multiphase, that is, consisting of several phases of aluminium oxide rather than solely corundum. The production process can therefore be optimized to produce a tailored product. The type of phases present affects, for example, the solubility and pore structure of the aluminium oxide product which, in turn, affects the cost of aluminium production and pollution control. For its application as an electrical insulator in integrated circuits, where conformal growth of thin film is a prerequisite and the preferred growth mode is atomic layer deposition, Al2O3 films were prepared by the chemical exchange between trimethyl aluminum Al, CH3, 3 and H2O, 2 Al, CH3, 3 plus 3 hours 2O Al2O3 plus 6 CH4, H2O in the above reaction was subsequently replaced by ozone as the active oxidant and the following reaction took place, 2 Al, CH3, 3 plus O3A. Al2O3 plus 3 C2H6, the Al2O3 films prepared using O3 show 10 a Euro 100 times lower leakage current density compared with those prepared by H2O. Known as alundum or aloxite in the mining, ceramic, and materials science communities, aluminium oxide finds wide use. Annual world production of aluminium oxide is approximately 45 million tons, over 90% of which is used in the manufacture of aluminium metal. The major uses of specialty aluminium oxides are in refractories, ceramics, and polishing and abrasive applications. Large tonnages are also used in the manufacture of xylides, coating titania pigments, and as a fire retardant smoke suppressant. Applications: the great majority of aluminium oxide is consumed for the production of aluminium, usually by the HAL-A-Euro-HA copyright Rowold process. Filler: being fairly chemically inert and white, aluminium oxide is a favored filler for plastics. Aluminium oxide is a common ingredient in sunscreen and is sometimes present in cosmetics such as blush, lipstick, and nail polish. Catalysis: aluminium oxide catalyzes a variety of reactions that are useful industrially. In its largest scale application, aluminium oxide is the catalyst in the Claus process for converting hydrogen sulfide waste gases into elemental sulfur in refineries. It is also useful for dehydration of alcohols to alkanes. Aluminium oxide serves as a catalyst support for many industrial catalysts, such as those used in hydrodesulfurization and some Ziegler-Natta polymerizations. Purification: aluminium oxide is widely used to remove water from gas streams. Other major applications are described below. Abrasive: aluminium oxide is used for its hardness and strength. It is widely used as an abrasive, including as a much less expensive substitute for industrial diamond. Many types of sandpaper use aluminium oxide crystals. In addition, its low heat retention and low specific heat make it widely used in grinding operations, particularly cut-off tools. As the powdery abrasive mineral aloxite, it is a major component, along with silica, of the Q-tip chalk used in billiards. Aluminium oxide powder is used in some CD-DVD polishing and scratch repair kits. Its polishing qualities are also behind its use in toothpaste. Aluminium oxide can be grown as a coating on aluminium by anodizing or by plasma or electrolytic oxidation. Both its strength and abrasive characteristics originate from the high hardness of aluminium oxide. Paint: aluminium oxide flakes are used in paint for reflective decorative effects, such as in the automotive or cosmetic industries. Composite fiber, aluminium oxide has been used in a few experimental and commercial fiber materials for high-performance applications. Alumina nanofibers in particular have become a research field of interest. Aluminum oxide is used as a catalytic fuel, which decomposes hydrazine in chemical reaction monopropellant rockets. In lighting, transparent aluminium oxide is used in some sodium vapor lamps. Aluminium oxide is also used in preparation of coating suspensions in compact fluorescent lamps. In chemistry laboratories, aluminium oxide is a medium for chromatography, available in basic, acidic and neutral formulations. Health and medical applications include it as a material in hip replacements. As well, it is used as a dosimeter for radiation protection and therapy applications for its optically stimulated luminescence properties. Aluminium oxide is an electrical insulator used as a substrate for integrated circuits but also as a tunnel barrier for the fabrication of superconducting devices such as single-electron transistors and superconducting quantum interference devices. Insulation for high-temperature furnaces is often manufactured from aluminium oxide. Sometimes the insulation has varying percentages of silica depending on the temperature rating of the material. The insulation can be made in blanket, board, brick and loose fiber forms for various application requirements. Small pieces of aluminium oxide are often used as boiling chips in chemistry. It is also used to make spark plug insulators. Using a plasma spray process and mixed with titania, it is coated onto the braking surface of some bicycle rims to provide abrasion and wear resistance. See also. References. External links, media related to aluminium oxide at Wikimedia Commons, CDC, NIOSH Pocket Guide to Chemical Hazards.